Hello class, we're about to start lesson 8 combination. Combination with one type of item. Sometimes the GED mathematical reasoning test will ask you how many ways you can combine a set of items. Sometimes you may have only one type of item to combine, and sometimes you may have more than one type to combine. This difference will determine your problem solving strategy. Consider an example with only one type of item. Pablo is going shopping at a fruit stand that sells apples, bananas, grapes, and pears. Pablo will buy two different kinds of fruit. How many combinations of two kinds of fruit could Pablo buy? The question is asking you to list possible groups of two out of the overall set of four. Notice that order doesn't matter. That is, apples and bananas is no different than bananas and apples. To solve this problem, you can make a list. Start with apples and list all the combinations that includes apples. You get apples, bananas, apples, grapes, apples, pears. Then make a list of groups that start with bananas and include the remaining fruits: banana, grape, banana, pear. Don't include banana, apple because that's the same as apple, banana. Then make a list of groups that start with grapes and include only the remaining fruits. So it'd be grapes and pears. There are no remaining groups that start with pear. You may find it easier to make this list in columns as follows. So what they did here, they put all of the apple combinations here, the banana combination, and the grape combination. Okay, now there are 6 possible combinations. You can also draw a quick table like the following. Include a column for each of the fruits and let each row represent a possible combination. Place 2 X's in each row to represent a combination of 2 fruits. Okay. Notice that you cannot draw any more rows with 2 X's without duplicating some of the existing rows. Count the rows. There are 6 possible combinations of 2 fruits. Now, we come here to this first exercise. Use counting an organized list or table to solve the following problem. As a supervisor, Rob is choosing 4 of his employees to work on a special project. The employees are Angela, Barbara, Colin, David, and Elizabeth. Of those 5 employees, how many teams of 4 are possible? Okay, so now, this is interesting because we have to do this as a table of 4. Okay, class, because of time constraints, I went on and wrote this out, and I'm going to explain it to you. Now we have Angela, Barbara, Colin, David, and Elizabeth. These are the combinations. So your answer here, how many teams that he can make is 5. Because remember, we don't want any teams repeating. And when I mean repeating, it doesn't matter if the letters are shifted around. If you have the exact same letters, whether they're shifted around or not, that is considered repeating, and we do not want that. So with number 1, I put Angela, Barbara, Colin, and David. Then I went Angela, Barbara, Colin, Elizabeth. Then I went Angela, Barbara, David, Elizabeth. Then I went Angela, Colin, David, Elizabeth. And then finally, it'll be Barbara, Colin, David, Elizabeth. These are the only combinations that you can have. So your answer here for number 1 would just be 5. So for number 1, I just put this here. You would just put 5. And that's based off of this here. Now you can pause this and copy this down, but this is basically how it's supposed to be done. Now, let's go back here to number 2. It says Jessica wants to take 3 books on vacation with her. She has 5 books to choose from. How many possible combinations of 3 books could she take on vacation? So we want to take a look at that. Okay, class, just like I said before, for the sake of time, I'm going to have this already written out for you, and then I will go and explain it. I just named the books LMNOP. Okay, so when we look at the combinations, We had LMN, LMO, LMP. Then we could do LNO, LNP. So far, no repeaters. Then we could do LOP. We can go to MNO, MNP. Then we could go MOP and NOP. And that gives us a total of 10. So our answer here would be 10. That's how many combinations you could do with those books. Okay, now we move on to problem 3. Grant is cooking a homemade pizza, and he has the following toppings available: anchovies, ham, mushrooms, and sausage. He would choose 3 of those toppings. How many ways could Grant combine these toppings? Okay, now, if we look here at number 3, okay, class, like I did in the previous problem, number 3, you have anchovies, ham, mushrooms, and sausage. If you see here, we got anchovies, ham, mushroom. Then we have anchovies, mushrooms, and sausage. We have ham, mushrooms, and sausage. And we have ham, sausage, and anchovies. These are the only combinations, and your answer here would actually be 4. There's only 4 combinations that you could use. Okay, now we move down to number 4. It says 5 friends want to play a video game designed for 2 players. How many different combinations of 2 friends are possible if the order of the friends does not matter? Okay. All right, just like we did the other problems, out of 5 friends, we were not given names, so I just put LMNOP. And we have here, this is friend 1, the L. So it go with M, go with N, go with O, go with P. Those are your first 4 choices. Then the second friend, M, will go with N, O, and P. So remember, we don't want any repeaters. Then we have N with NO, NP, and then finally OP. Any other combination will have us repeating what we already have. So our answer here would be 10. Okay, so now we go to problem number 5. It says Celia is going to plant a small flower bed with 4 flowers. She could choose from begonias, fuchsias, hellebore, daisies, and salvia. How many combinations of 4 flowers are possible? Okay, class, these are the ones that we have from the flowers. We have BFHD, BHDS, FHDS, FDSB, SBFH. And these are your 5. So your answer here would be 5. All right. Now, we go here to number 6. Regan owns a small business and she wants to send 3 people from her business to an upcoming trade show. Since Regan plans to attend, she will only choose 2 of her 4 employees to also attend. How many combinations of employees could Regan choose to send to the trade show? She wants to send 3 people from her business. So she's going to choose 2 of her 4 employees. So, with that being said, okay, class, these are the combinations because we don't know the name of the employees. But remember, it's 4 of them, but only sending 2 of the 4. These are the combinations: LM, LN, LO, MN, MO, NO. Okay, now, we go down here to number 7. It says, oh, you know what? I have not marked these. So wait a minute. This is supposed to be 6. And I need to give the letter answer for number 6. Number 6 is supposed to be B. And number 5 for 5 was supposed to be A. So these were your answers. Number 5 was A. Number 6 was B. Okay, now we go here to number 7. It says a book club which has 2 women and 3 men can send 3 of its members to a book signing. How many possible combinations of members could attend the book signing? They said they could only send 3 of its members. So it's actually 5 members. Okay, class, I don't want to reinvent the wheel, but if you look back at problem number 2, problem number 2 is basically the same setup as problem number 7. There's a total of 5, and you have to pick 3 of those 5. So this gave you the different combinations. The combinations would be the same. It's just that it would be in problem number 7. So what I'm going to do, I'm going to copy this. See if I could copy this in this different program here. Doesn't seem like it's letting me copy. And I will put this down here so you can have this in your notes. So these are the combinations. It's still 10, and those are the combinations of possible members of the book club you could send. So your answer here would be 10, and then our letter would be C. Sometimes you have to look around a little bit to see if the questions are basically the same, so you don't have to reinvent the wheel. Okay, number 8. It says, given 6 people, how many combinations of 3 are possible if order does not matter? Okay, class, as you see here with number 8, I have 18 different combinations. Now, remember, when we're doing these problems, it tells us to choose the one best answer to each question about combinations. So let's just say that with my doing this, that I did not list all of the combinations. But you see the one that is closest to. The one that is closest to for number 8 is A, which is 20. So your answer here for number 8 would be 20. So it'll be 20, and your answer is the letter A. Okay, so now we go down here to number 9. It says the Sarkeesian brothers own a hardware store. There are 5 items the owner might display in the window. Joe Sarkeesian thinks that the window should have 2 items, but his brother Rick thinks the window should have 3 items. Counting both Joe's idea and Rick's ideas for the window, how many possible combinations of items might go into the window display? Okay, now for number 9, if you notice here, I use LMNOP to designate the different items that these 2 people have. And so what I did, if you go back to question number 7 talked about 5 items and you pick 3. Question number 4, if you go back to question number 4, go back here. Question number 4 talked about 5 items and you only picked 2. So what you were supposed to do here is take the results you got from number 7 and number 4, and that will give you all the results for both brothers for a total of 20, because they were 10 apiece. So your answer here would be 20, which would be B. And that concludes this lesson, and I will upload this to YouTube. Have a wonderful day.